Hello, my name is Ritvik, and I'm presenting the proposal for Project Group 8. The title of our proposal is Used Cars Price Estimation. So today I'll be talking about our motivation, our data set and the task we're going to do with it, the visual encoding, and the data modeling. So let's start with motivation. So the goal of our project is to find the cost of a used car by visualizing all of its different columns, so brand, manufacturer, transition type, and many others. And we got this from a data set from an expert who has went through all these things and figured out the price evaluations for cars. So our main objective is to create a model that, based off previous data, can estimate the price of a used car and display it using different visualization techniques. So, some questions of interest. The number of people who wants to sell their cars, which state has the highest demand for used cars. These all sort of go for different columns in our data set. What time of year are used cars sold the most? How much on average are users willing to spend on used cars? Which brand of used cars do customers prefer the most? And which manufacturer has the highest resale value? And which car size is sold the most? So all of these questions you see here are all things that change the price of a car. You know, your state is very important. The demand is very important. So these are questions that are very important to what we're trying to do. So let's go over the data set and the task. So the data set we used is from Kaggle, and we got it from the author Austin Reese, who gathered it from Craigslist. Craigslist sells a lot of used cars. So there are a lot of rows, over 500,000 rows, and we took 13 dimensions of this data set. So the original data set was much bigger, and we'll talk about that more when I get into the sort of data cleaning section. But these are the columns we have selected for our data set. This is what we're going to be focusing on. This is what is we're going to visualize and in turn find the price of any given car given these other dimensions. So dataset cleaning. So we had to remove a lot of unnecessary columns, things like the Craigslist URL, the region URL, the latitude, the longitude, the description, the vehicle identification number. These aren't really important for finding the price of a used car, so we just had to take them out because they don't fit our goal. And the second step is some of these columns had null values, even the ones that are important for the price of a car. So you sort of have to have some default values. For example, a lot of cars are two-wheel drive or four-wheel drive. So if it had a null value for the drive, we could just say it's a two-wheel drive. That's like the default value. And furthermore, cars with a model value greater than 2009 were filled in as new, with a model value between 2017 and 2019 were filled with like new. So what we did is we used some data from other columns to sort of data mine information that we could use to fill in the null values that were in the data set. So the visual encoding. So here are the initial findings with price versus manufacturer. So the manufacturer, you'll see there were some null values in the count of price, but here we can see that manufacturer does have a pretty noticeable impact on price, and that's one of the reasons we picked it in the columns we selected for our initial data set. Here we also see type versus state. The reason we have to do these sort of interconnected analysis is because sometimes states can have certain biases towards certain types of vehicles. So you see, of course, sedan and SUV are very popular, but so pickup trucks are very popular in more sort of suburban and countryside states. So we have to take those into account when creating our model. And the final graph we have here is the number of sales per state. So obviously, highly populated states are going to have way more sales, but we can't weigh them too heavily because, of course, you saw earlier that certain states prefer different types of cars depending on their needs. So this is just another way to sort of show how we're going to weight everything when it comes to all of the columns. So here's a prototype of what our sort of visualization application is going to look like. So we have the estimate here, and in the estimate you can see enter in all this different stuff: manufacturer, drive, condition, title, status, state, model, all this stuff. And the idea with trend is that you'll be able to see sort of based on what you've entered in what prices you're looking at before you even get an estimate. So it sort of gives you an idea, a visualization of the data just based off your current selections. And then once you've entered in what you want to enter in, you can get an estimate as to the final price of your car, and that will be our end goal. So yeah, this is our prototype that we're working towards. Now let's talk about the data modeling. So of course, we're trying to find the price of a used car. So if a user comes in and uses our prototype and wants to enter information that's new, the only way we can sort of get that information into a prediction of the price is by using machine learning. So we're going to use a sort of logistic regression algorithm in order to process each column and get a prediction for the final price. And some of our data is categorical. Of course, machine learning sort of requires all of the data to be numerical in nature, but luckily we can just turn the categorical into numerical values pretty easily by using a logistic regression model, because that'll stay the most flexible to sort of step variables like categorical variables to accurately predict the price of a new car. The expected outcome is that the logistic regression is going to return the weights and the bias, and then with these two values we'll be able to plot the trend that you saw earlier that I was talking about with our prototype. So you'll be able to get an idea of roughly the price before you even enter all your information. And we can also assess how well the model works by using a loss function. Of course, some of our data is going to be unlabeled, but that's okay because we can sort of predict the price anyways. You know, obviously cars have value based on different aspects, and we can figure that out even if our data is unlabeled, our test data. And the error function we'll use is mean squared error because our model is focused on regression rather than classification. And that is it. Thank you for seeing our proposal.